How bats see with their ears.
And we're going to rattlesnake country in Texas to find out how these little critters can see in the dark.
And I'll be in the greenhouse, helping a plant that hasn't seen the light.
3, 2, 1. Contact is the secret, is the moment when everything happens. Contact is the answer, is the reason why everything happens. Contact. Let's make contact. 3, 2, 1. Contact.
Good evening. The Count here again among the creatures of the dark. My dark. Night-drooping blossoms, rodents, reptiles, and other dwellers of the dreadful darkness. Brought to you by Transylvania Airways. We get you there as crooked as a bat flies.
5, 6, 7, 8, 9, 10, 11, 12. We're missing one whole plant. Where's the Swedish ivy?
Well, it's got to be here somewhere. Oh, wait, didn't we put it under the faucet to soak?
That's right.
It's not here.
Hey, you guys looking for something?
Yep,
Yeah.
Mrs. Roth's Swedish ivy. We have to find it because she's coming back from vacation tomorrow.
You didn't lose it. I put it on the TV. I thought it looked kind of good over there.
Oh, Mark, no.
Look at that plant.
It's all stringy now.
Oh, we can't give it back to Mrs. Roth like this. She'll never trust us to take care of her plants again.
Tell you what, I got a great idea. We'll call a botanist. Quick.
It was such a pretty Swedish ivy, too. She's going to think we didn't feed it.
Mr. Amarato.
Phil.
Phil, okay. We've got this Swedish ivy here, and it's in pretty bad shape. What's wrong with it?
Sure is.
Yeah, it sure is. The lower leaves are either very small or have fallen off. The upper leaves are okay, but the stem is very long and the plant is leaning.
Well, what do you think is wrong with it, Phil?
Yeah.
Well, what do you think is wrong with it?
I have no idea.
Neither do I.
Not enough water?
Well, feel the soil.
It's moist.
Yeah, and the soil's pretty good.
All right, so that's not it. And it hasn't been overwatered because then the ends of the leaves would be brown. Well, what else?
Maybe the heat from the television. That gets
Yeah,
pretty warm.
that's
That's a good guess, but then the leaves would be wilted, and they're not.
Well, how about light?
Exactly. Plants need a certain amount of light. When they don't get it, they're in distress, and they're always reaching for it. This will do better here
why don't I move
in the
this?
greenhouse where there's a lot of light.
Phil, they can't really see the light, can they?
Well, not the way we do, but they do perceive light and respond to it and grow towards it. And it's done in an interesting way. The cells on the side away from the light grow more than the cells on the lighted side, and that causes the stem to bend towards the light.
Well, how do the cells know how to do that?
Well, there's a chemical produced in the tip of the plant that moves down the stem, and more moves on the non-lighted side, and therefore those cells grow more.
What's that chemical called?
It's called auxin.
But what about plants that are in the sun all the time and get plenty of light?
Yeah.
Well, in that case, the auxin moves down evenly, and the stem grows perfectly straight. But remember, the reason that plants bend towards the light is that they need light energy in order to grow. It's a process called photosynthesis.
How does that work?
Well, the leaf traps the light energy. It also removes carbon dioxide molecules from the atmosphere, and from it makes sugar. And on that sugar, it lives, and we live if we eat the plant.
Right.
Bill, how come in most plants anyway, the leaves are usually green completely, or at least part of them are green?
That's the most important chemical. That's called chlorophyll, and it's the chemical that traps the light that allows photosynthesis to proceed. And that's why all plants are green, because they all have chlorophyll.
Every tree must find its place in the sun. Without sunlight, neither a tree nor any green plant could grow. When sunlight meets the leaves of a plant, it excites something green called chlorophyll. When this chlorophyll combines with the water in the plant's leaves, amazing things happen. First, the plant takes in an invisible gas called carbon dioxide from the air, and then it combines part of the water and the carbon dioxide to make sugar. Then the plant lets out another gas, oxygen, into the air. All animals depend upon plants for food and oxygen, and plants use the carbon dioxide given off by animals. So, animals and plants both depend on the sun. Every day the plant takes in sunlight and water and carbon dioxide to make sugar, which gives it the energy it needs to grow from a small plant to a big plant.
So you see, there's really only one cure for this plant, more light. And since it's winter and the days are short and the light isn't particularly strong, you can supplement the light with some plant lights, like the ones I see you have around.
Does it have to be a special light like that?
Well, these work very well, the special lights, but almost any light will do.
And so the plant will respond to the light the same way it responds to sunlight?
That's right. It'll use the light energy to perform photosynthesis.
So what do plants do at night when there's no sun?
Well, obviously they can't photosynthesize, but what they'll do is live off the sugar they produce during the day and do all sorts of things, including some very special things. But remember, plants require light. Without it, they just won't grow. Now, that's not true with animals. In fact, there are certain animals that prefer the darkness.
Really? You mean they've adapted to night?
That's right. They're called nocturnal animals, and they're quiet during the day, and at night they really come to life.
That's like fireflies.
That's right.
Science salutes fireflies. Not flies at all, but shining members of the beetle family. They're little lanterns lit with chemical juices. They flicker on summer evenings a language of lights, a special code that only they can understand. The lady firefly, no lady at all, uses her gorgeous lantern to cast her alluring spell. Setting her sights on some bold male flyer, she tempts him to her side by bringing her buxom belly in time with his. But even then, her beetle babies on their way, she's not above this femme fatale, using her lights again. One male after another answers her call and becomes supper for the beetle woman.
What are some of the special things that plants do at night?
Well, certain plants actually flower at night.
Why do they flower at night, not in the day?
Yeah.
Well, they flower at night because the pollinators, the animals that pollinate them, are out at night. They're nocturnal animals. For example, the calabash, which has a flower shape just like a radar dish, is pollinated by bats.
That's how you go bat catching, huh?
Yes. That's just the way it is in a cave, for example.
Even though I'm here to learn about bats and everything, I'm really not too sure about them. They're kind of scary-looking animals.
Okay. Bats are nothing to be afraid of. Here's a small to medium-sized bat from Africa. There's a wing, which is fingers, just as in the hand.
Oh, these
with
things?
a thumb sticking up on the end, right there. Bats can see pretty well. It's just that they usually use their eyes to avoid the light. So when they go out, they're ordinarily in a place where there isn't any light.
This particular bat right here, is this one of the smaller bats?
All right, this is a medium-sized bat. There are bats that are smaller and bats that are bigger. The smallest bat has a wingspread of only about 4 inches and is hardly the size of a big butterfly. The largest bat, we have one over here. They have wingspreads up to about 6 feet. This is Oppo, one of the largest kinds of bats that there are. It's a kind of flying fox. As you see, this one's wingspread is about 3.5 feet. It's a nice, friendly, tame bat that will sit in your hand. They make good pets.
Is this your own personal bat?
This is one of our laboratory mascots. It's a wonderful bat. This kind of bat sees and uses its eyes to find its way around. It eats fruit and lives in Africa and Asia, in the tropics.
Will this kind of bat fly around during the day?
They'll hang in trees during the day and squawk at one another, and at night they'll fly around and look for food, bananas, things of that kind. Most bats are much smaller than this, and they don't fly around looking for fruit, they fly around looking for insects to eat.
Which one of these bats do you use in your research to find out things about them?
All right, we study smaller bats, like the one here. This is a big brown bat, common all over the United States. This one comes from here in Missouri. This bat finds its way around in the dark using sounds rather than using its eyes. The bat can fly 20 or 30 miles an hour through a forest, chasing insects to feed on. The bat makes sounds that travel out from the mouth, bounce off objects, trees or insects, and come back to the bat's ears. And the bat hears the echo of the sound, and can tell all it needs to know about the objects.
But how does it tell exactly how far away the tree or the moth is?
Suppose you're bouncing a ball off a wall. The time it takes the ball to hit the wall and come back to your hand is shorter if you're closer to the wall. That's how the bat tells the distance.
Oh, I see. Even though it's flying?
Even though it's flying, all this happens very quickly. When a bat's chasing an insect, from the time it detects the insect in front of it to the time it closes in and catches the insect is less than a second. When you see a bat flittering around in the sky, changing direction and jerking around, each time they turn sharply, they've caught an insect and they're moving on to chase another.
Really?
All night long. It's amazing.
So if you know all that information already, what are you trying to find out with your experiments?
I want to know how the bat's brain draws the picture of the things in front of the bat using just the sounds. Without any light at all, the bats act as though they can see things, but they use the sounds to get the picture.
How do you do that?
We have a soundproof room in the laboratory. We bring the bats into the room and study them there. This bat has been trained to sit on the platform and make sonar sounds at the objects in front of it to get echoes back. The bat will tell the difference between the larger object and the smaller one from the sounds.
So it sits up there, sends out the ultrasonic sounds, which will bounce off of these objects. It'll go back to the bat, and he'll be able to tell which one is the large one.
That's right. The sounds bounce off the object, and the larger object produces a louder echo.
Then what will it do?
Then it will move forward in the direction of the object that's larger, in this case from here to here. I think this bat is about ready for the experiment now. Mark, why don't you come around here and get a bat's eye view?
Okay.
I'll switch out the light.
Jim, I can't see a thing.
I'm your Science in the News reporter. Ow! Speaking to you from the depths of a pretty dark cave. I'm here today, to talk to some people who really live in the dark. Oh, I'm sorry, sir, I didn't see you there.
Not to worry, I just materialized.
Sir, could you give us a moment?
A moment, a century, eternity, but not now. I must be off. Night work, you know. Talk to my little friend, the bat, in there. Bye-bye.
He's weird.
Hi there, you seem to be a little in the dark. Can I help you?
Well, I hope so, little friend.
You know, you shouldn't be running around in the dark without sonar.
Probably so. When do you expect him?
Sonar, sir, is not a him or a her. Sonar consists of these little sound waves I send out.
I don't hear anything.
You don't, but I do. Let me demonstrate through the magic of television. Pretend these lines are sound waves. I send them out. And they bounce back off you, giving me a picture of you.
That's fantastic, isn't it, folks? But since I don't have sonar, what do you suggest I do?
Wait for Harvey. He'll be coming through with a guided tour. One other suggestion, though. I wouldn't step forward if I were you. It's a long way down.
I'll put on a little light so that you can see.
Why is he moving his head back and forth like that?
Well, the bat is looking around with its sounds. It's scanning the objects on the left and on the right.
He's kind of checking things out with sound.
That's right.
He did it.
Yes, he did.
What would happen if these balls were just a little bit closer in size?
Good question. Let's replace this one with a little larger ball and see what happens.
That's fantastic. He got it again. But how do you know he just doesn't go over to that side?
Well, let's reverse the balls and see what happens.
He still got it. I'm convinced. That's great. Well, I'll tell you, I wish I had some sort of radar so I could walk around at night like that. That's really excellent.
Many animals come out at night. Some come out to feed, often on other animals.
Like rattlesnakes hunting their prey in the dead of night. Dusk in Kingsville, Texas. That's rattlesnake country. And sundown is when the snakes come out to hunt. Their prey? Rodents like the wood rat. The rattlers can't see them at night, but still strike in the dark with deadly accuracy. Dr. John Perez is an immunologist. He's a snake poison doctor, and he's been studying this nighttime struggle between rat and snake to find a better cure for snake bite. He really knows his way around rattlesnake country.
This is typical South Texas terrain in which we have heavy brush cover. In addition to that, we have grass and cactus, which are very useful for the animals that live in this area. The rattlesnake and wood rat can live in close proximity because there's adequate brush cover, material to build home sites for the wood rat, and adequate food material such as the cactus. The wood rat is not like the city rat. The city rat is a scavenger and carries many different types of disease. The wood rat lives in the country and feeds often cactus and cactus fruit and would build nest sites for its young. The rattlesnake lives here for some of the same reasons. It's more or less a dry climate. There's adequate food here, which is some of the small rodents that live in this area. The fact that the rattlesnake uses small rodents for food is good, and this keeps the proper balance of these animals within the environment. Both of these animals are primarily nocturnal. The rattlesnake will come out in the day, but primarily it does most of its hunting at night, and for this reason, their eyes are not well developed, and they really don't depend on their sight to capture their prey. But they have a well-developed heat-sensing organ, or infrared sensing organ, which they can detect the heat of warm-blooded animals, such as the wood rat. But now the wood rat has also developed a protective device in that it has a natural resistance. It has a factor within its blood that will allow it to resist the toxic action of the rattlesnake venom.
Most people think that snakes are slippery and slimy, but they are actually dry and cool. In between the nostril and the eye, you can see the heat-sensing pit. Now let me lower its bottom jaw, and you'll be able to see the fangs. The fangs are extremely large. Here we have dried rattlesnake venom, and this small amount is the amount that would kill white laboratory mice. Wood rats have a natural resistance. This amount of venom would kill a wood rat.
Look away if you want. I almost did. But here's what happens very quickly when a rattlesnake bites a white mouse. But when the wood rat is bitten by the rattlesnake, his natural immunity helps him survive the attack. You got to understand that these experiments help doctors find better antidotes for snake bite in case you get bitten by one of these critters.
We inject goats with dilute solutions of venom, which really doesn't hurt the goat, over a period of 3 or 4 months. And then in about 3 months, these animals will produce an immunity to the venom, and we compare this immunity with that resistance that is found in wood rats.
While every night out in the desert, the natural hunt goes on. The rat running, the snake slithering, striking in the dark at a creature he never sees.
I know some people who are never in the dark. Who? The Bloodhound Gang.
Whenever there's trouble, we're there on the double. We're the Bloodhound Gang. If you've got the crime, we've got the time. We're the Bloodhound Gang.
Mr. Bloodhound did not return from his morning walk on the day he was scheduled to testify against the notorious Sniffle Gang. Mrs. Bloodhound suspects foul play. Mr. Bloodhound sent a note with several crossed out words and signed with a phony middle name, James Trez Bloodhound.
Means 3 in Spanish.
Vicky suspects it's a coded message. There may be a clue in the coded sampler hanging on the wall of Mr. B's study. It means home sweet home.
Got it.
The Bloodhound Gang discovers that Mr. B's code was based on shifting the letters of the alphabet 3 spaces. The Bloodhound Gang quickly decodes the message. Now for the conclusion of the case of the missing bloodhound.
There it is, room 6.
You looking for someone?
Shh. The people in room 6.
They can't hear you. Skip, a lot of them.
Did one of them carry a walking stick? How many were there?
3. Say, who are you asking all these questions?
Bloodhound Detective Agency. I hope you haven't cleaned the room yet.
Just about to.
There may be clues. We'd like to look around.
Oh, come to think of it, I did see one of those men with a stick under his arm when they came in.
Mr. Bloodhound may have left a message on the wall or something.
Mr. Bloodhound's belt. That's his buckle.
A belt?
Yeah, with letters scrambled on it.
Hey, I was just reading about that. The Greeks used to send secret messages on belts.
Another code.
Nothing to it. You break the code by rewrapping it around something round. But it's got to be exactly the same size.
Then we've got to find whatever it is Mr. Bloodhound used to coil it around to write the message.
Right.
The lamp. Let me try it.
Nothing. That's not it. It's got to be in this room. The chair.
No, and we're running out of time.
This ought to break the code, Mr. Bloodhound's walking stick. Warehouse. Bloodhound.
What have they done to him? Where is he?
Chatto's warehouse. He must have heard them talking.
I called the police as soon as I got your message. Come on, there's no time to waste. Where's Mr. Bloodhound?
He left him this way.
I knew he'd pull a Houdini.
And he left a note, look. This is a note you won't have to decipher. Meet me in court, signed Bloodhound. P.S. Bring me a belt.
Today we've discovered how some living things live in the light and some live in the dark. From plants that reach out to the sun for energy to animals that have ways of living in the dark.
All right, let's get back to Mrs. Roth's plant. It obviously needs a lot of care. What are you going to do?
Well, I think we should leave it in the greenhouse for one thing.
And water it.
And we definitely have to keep it away from the television.
Right.
But remember, for this plant, and in fact for all plants, light is extremely important because it powers photosynthesis, and photosynthesis gives sugar to the plant and also to the whole food chain. And it's on the basis of that sugar that we all can lead the lives we do.
Yeah, as a day person.
Or a night person.
Or a little bit of both, right?
Yeah.
321 Contact is a production of the Children's Television Workshop.
Meyer and Frank and Keds join OPB to present Paul Horn and Portlander John Stowell at the Washington Park Zoo Wednesday night at 7. Admission is $5.